Number 12 from page 317 in Barron's workbook. Says the total area bounded by the cubic function x equals y cubed minus y and the line x equals 3y. Now, if we sketch this out, this is going to be the black line is going to be the linear function, and the purple line is going to be this cubic function. And the easiest way to find the area between these two curves, which I'm going to maybe highlight here. Okay, so that area and the other area on here. The easiest way to do this would be to use the rectangles, horizontal rectangles with a dy. So I'm going to do this with dy. Now to do this with dy, we need x equals equations, which we already have in this case. And we're going to subtract those in this case because we want to find the difference between those two lines to get the horizontal width. And using that horizontal width, we're going to use dy and then get area that way. There's another thing that we're going to do here, in that we're only going to integrate from 0 to 2 because it is a symmetrical diagram, and if we find out the area on the top half, we can double it for the area on the bottom half. Now, how do I know my bound is going to be 2? Well, I need to solve for this. So I'm going to make these x's equal to each other. So I'm going to have y cubed minus y. That's going to be equal to 3y. And then I'm going to solve this equation to find the bounds of this. So solving this, I get y cubed minus 4y equals 0. I end up with y squared minus 4 equals 0, and then I get y minus 2, y plus 2 equals 0. So I get y equals 0, negative 2, and positive 2. Okay, so that gives me my y intersections, and I can see them all occurring here. So there's my 0, there's my positive 2. Now I'm going to set up my integral. So the area that I'm calculating is going to be based on that rectangle. So to get that rectangle, I need the horizontal width. To get horizontal width, I need to subtract two x positions. So I'm going to take the x position of 3y, and I'm going to subtract that cubic function position, which is y cubed minus y. This will give me the horizontal width of the rectangle. I then need to multiply that by dy to get area. And then I want to sum up those rectangles. So I'm going to take the integral and I'm going to do from 0 to y equals 2. So this is y equals 0 to y equals 2. My equation's all in terms of y with a dy, so that's compatible. Same with my bounds. My bounds are in terms of y. And this is going to give me a half area. And I'll just double it to work out the full area. So my half area is going to work out to be, I'm going to first combine like terms. So I'm going to have 4y minus y cubed. And then I'm going to use a dy. I'm going to integrate this. So I end up with 4y squared over 2 minus y4 over 4. And I'm going to use my bounds 0 to 2. So then plugging this in, I'm going to simplify first. Plugging in my bounds, I'm going to end up with, plugging in the 2, I end up with 8 minus 1. Oh, sorry, that's not 1. That's going to be 2 to the power 4 is 16 divided by 4. So 8 minus 4 minus, well, I'm going to plug in 0, so I get 0. So my half area is going to work out to be 4 units squared. So that the top half of that is going to be 4 units squared. So I'm going to double that area. So my answer is going to be 8 units squared. Okay, so then when I work that out, that's my final answer.